All right, a couple more questions from section 2 of chapter 4. And so let's look at number 7. And so it's looking at the predicted grade point average. Like if we have these numbers and we want to calculate the predicted GPA, we first have to make sure that we know that number of video games played each is X and grade point average is Y. So this is our least squares equation, which is our predictor equation. So if I wanted to figure out what the prediction of GPA is, I would use this formula, and for X, I'd plug in 8. So using my calculator, I had negative 0.0597 times 8 plus 2.9278. And this should be my predicted GPA, 2.4502. And that's not correct. Oh, round to the nearest hundredth place. Gotta follow directions on these things. And so, well done. And so for each addition hour that a student spends playing, this is important, knowing what the slope means. So for each addition hour that a student spends playing a video game in a week, the grade point average will, well, this is my slope. This tells me for each additional hour what goes on. So the slope tells me this, and it will decrease because it's a negative value by the 0.0597. Interpreting the y-intercept, right? So basically the y-intercept is this value. If someone doesn't play any video games, this is what their GPA, average predicted GPA, should be, that 2.9. Who does not play any video games. And then a student plays video games 7 hours per week, has a grade point average of 2.40. So this is just a particular student. If the student's GPA above or below what would be expected. So now I could just go into here, and instead of 8, let's see what 7 would be. And it gives me a 2.5099. This is what's expected, right, off of our prediction equation. So this person's actually doing worse, is below average. And so just different ways you can ask the question. I also want to look at number 12 from the homework. A lot of people get number 12 wrong because they don't consider this R value. They take the data, they make an equation out of it, and they think they're doing everything right, which, you know, you are making a regression equation. But should we use this regression equation? And so the thing is, when you look at your critical values for a correlation coefficient, sorry, I didn't look at the number of data. We had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 data points. If we have 10 data points, it really needs to be higher than a 0.632. Again, we're comparing this to a 0.2237. We don't need to look at the sign again. Look at the absolute value of R. And so 0.2237 is not higher than 0.632. Therefore, there's not enough evidence to show that they have a linear relationship. So, what does the book say to do in this case? When there's no linear relationship, to predict a value, we just use the average of our y values if we want to predict the response variable. So on this particular problem, if I want to predict the return, instead of looking at my regression of this value, I would just look at the average of my y's. And again, so we always have to look at that R value to say, does it follow a linear relationship? So I just need to find the average of my return and so it's 17.308 and 1 decimal place, so 17.3% would be my return. It's just the average. We're not plugging it in to the regression equation. Again, same thing for 25 million. It would be the same, right? Because it's not based on plugging 25 in, it's the average of my y values. And that's because my R value up here was too low. So don't neglect that.